I study proteins. And proteins have been thought to have one structure that has one function or fold. I'm studying this group of proteins called fold switching proteins. So they can actually change their structures and their functions in response to changes in the cell. So you can kind of imagine fold switching proteins are like a transformer, where in one case, the protein is like a robot that does one thing. And then in another case, in response to changes in our bodies, it becomes a car and can do something else. And an advantage to this is it can respond really quickly to changes in our bodies. Back in high school, I did not imagine myself being a scientist at all. Before going to college, I did kind of fall in love with math. Like when I took calculus, I was like, wow, this is so cool. It was like the first time I realized that math could be useful for something beyond balancing my checkbook. At the end of my sophomore year of college, my dad was diagnosed with stage 4 lymphoma. He went through multiple rounds of chemo, and it was just a really hard process. Just watching that happen and thinking, I wonder if there's a better way. Some of the proteins that I'm working on that actually do this phenomenon called fold switching are actually associated with diseases. So cancer, Alzheimer's, autoimmune disease, bacterial and viral infections. If by the end of my life, even one successful treatment was made based on this, that would be amazing. NLM has a really strong track record in computation. There are a lot of excellent scientists here, and so I thought it would be great to be able to work with them. I'm also really grateful to have the freedom to pursue what I want to do. And I'm really happy to be here and be able to take chances that I probably couldn't do in most other environments.